Quicker than the fabric of space-time can adapt, it's as though Betelgeuse might tear apart at any moment, a thrilling yet unsettling possibility captivating astronomers around the world. This red supergiant, adorning Orion's shoulder, is undergoing a spectacular transformation. Its glow, once steady, has surged dramatically, exceeding its usual brilliance by an estimated 50%. Earlier this year, Betelgeuse held the title of the 10th brightest star in our night sky. However, an unexpected burst in brightness has elevated it to the 7th position, dazzling even more brightly as it continues its journey. Betelgeuse is a massive star nearing the end of its life, so large that if it were at the center of our solar system, it would extend as far as Jupiter's orbit. Eventually, this star will collapse, resulting in a powerful supernova explosion, potentially leaving behind either a neutron star or a black hole. Humanity is well positioned to witness this cosmic spectacle, situated about 650 light-years away, a safe yet close enough distance to observe it in unprecedented detail. When Betelgeuse explodes, it will emit an initial burst of neutrinos detectable by observatories across the globe. Following that, high-energy photons will escape the expanding cloud of stellar debris, causing Betelgeuse to brighten immensely. Within a week, it could become up to 100,000 times more luminous than usual, potentially rivaling the brightness of a full moon and even casting shadows on Earth. This incredible event will offer a unique opportunity for detailed observation and perhaps groundbreaking discoveries. Despite some historical superstition associating such cosmic events with ominous signs, we can be reassured that we're at a safe distance from any negative impacts. To fully understand Betelgeuse's current state, we need to go back to late 2019, when unusual changes began. During this period, the red supergiant experienced a significant dimming, visible even to the naked eye. Observations using the Very Large Telescope in the optical spectrum showed that the star appeared largely uniform, yet its outer photospheric layers displayed signs of major disturbance. The photosphere, the star's outer layer where light is emitted, seemed to expand, a phenomenon observable from Earth. This expansion continued steadily, at about 8 kilometers per second, until mid-November 2019, when the outward speed began to decline. By then, the flow of material from Betelgeuse had ceased, prompting astronomers to capture fresh optical images of the star. These images revealed two startling findings: an obscured region in the star's southern hemisphere, contrasting sharply with previous images, and a drop in the star's surface temperature, cooling by approximately 80 Kelvin between January 27 and February 13, 2020. About a year after the peak of this dimming event, Betelgeuse slowly regained its brightness, ultimately returning to its typical state. This sequence of events raised a fundamental question: what had truly occurred with Betelgeuse? All available evidence suggested that Betelgeuse had undergone a rare and massive event known as a surface mass ejection, SME. Similar to a coronal mass ejection, CME, observed on our Sun, an SME on this scale is extraordinary. Imagine a volcanic eruption of star-sized proportions. Material from the star's interior bursts outward, creating shock waves in its atmosphere. Over time, this ejected material forms particles and dust that partially obscure our view of the star, causing it to appear dimmer. In Betelgeuse's case, the SME expelled a mass roughly 400 billion times larger than what's typically seen in similar events on other stars. This is comparable to several times the mass of the Moon, propelled at remarkable speeds. Scientists note that such a massive ejection from a star's surface had never been observed before. Using the Hubble telescope, this event allowed direct observation of surface details, providing real-time insights into the evolution of a dying star. The SME caused Betelgeuse to lose a substantial amount of mass in a single incident, highlighting that a dying star can experience significant mass loss beyond its usual stellar wind-driven decline. In a sense, Betelgeuse had dramatically shed its outer layer and is now in the process of gradual recovery. Since this dimming event, the star's behavior has shifted noticeably. Previously, it would pulsate or vary in brightness roughly every 400 days. Now it pulsates every 200 days. Betelgeuse, a semi-regular variable star, has known cycles of fluctuating brightness due to changes in its size and temperature. This red supergiant exhibits two primary periods of light pulsation: a 400-day period attributed to pulsations in the fundamental mode, and a longer, approximately 5.6-year cycle, the origins of which remain unknown. In their research, scientists use simulations to deepen their understanding of these events, proposing that an unusually hot gas bubble, a massive and intense pocket, emerged from within the star. Hot gas bubbles can sporadically arise due to the star's turbulent, convective envelope, similar to a pot of boiling soup with constantly churning and mixing material. As this hot bubble rose and broke through the star's surface, it triggered the extraordinary mass ejection and subsequent dimming of Betelgeuse, a momentous occurrence that continues to fascinate the scientific community. A massive star, also known as Alpha Orionis, has recently displayed behaviors that astronomers have never observed before. While the eventual supernova of Betelgeuse would be a breathtaking event drawing scientific and media attention, it isn't something humanity should fear, as it doesn't pose any danger to Earth. Observing a star's final stages provides a rare opportunity for astronomers to deepen our understanding of the life cycles of stars, the mechanisms behind their explosive deaths, and the formation of new cosmic structures. It's a reminder of the universe's dynamic, ever-evolving nature, inspiring ongoing exploration and understanding. Betelgeuse's transformation signals the nearing end of a star's life and its potential rebirth through a spectacular explosion of light. Located prominently in the constellation Orion, Betelgeuse has captivated both astronomers and cultural historians, not only for its cosmic significance but also for its mythological impact across centuries. As a red supergiant star nearing the end of its life cycle, it is massive and unstable. Its diameter is approximately 1,000 times that of our Sun, making it one of the largest known stars. Despite its enormous size, Betelgeuse is not stable. It pulses and changes in brightness over time, reflecting its internal turmoil and eventual demise. One of the most fascinating aspects of Betelgeuse for scientists is its potential to undergo a supernova explosion. While the exact timing of such an event is uncertain, scientists speculate it could happen any time within the next 10,000 to 100,000 years. As Betelgeuse exhausts its nuclear fuel, especially during the fusion of elements like helium into heavier ones such as carbon, oxygen, silicon, and eventually iron, its core will collapse under its own gravity. This intense collapse will trigger a powerful explosion, releasing immense energy and material into space. Even from its distance of about 650 light-years, a supernova from Betelgeuse would be a spectacular sight, temporarily outshining the combined glow of all the stars in the Milky Way. The aftermath might leave behind a neutron star or even a black hole, depending on the star's original mass. Astronomers worldwide closely monitor Betelgeuse, tracking its brightness and spectral changes for any signs of its impending explosion. Recent observations have provided fascinating insights into its variability, including shifts in its pulsation patterns and surface characteristics. Alongside its scientific importance, Betelgeuse also holds a significant place in human culture and mythology. Its name originates from the Arabic term Yad al-Jawza, meaning the hand of al-Jawza, referring to the star's role in the Orion constellation. In various cultures, Betelgeuse has symbolized different concepts, showcasing its prominent position in the night sky and its impact on ancient beliefs. For instance, in ancient Egypt, it was linked to the goddess Isis, representing rebirth, while in Norse mythology, it symbolized the heart of the giant Hraesvelgr, embodying strength and resilience. These interpretations highlight Betelgeuse's universal appeal and its role in shaping human narratives about the cosmos. Technological advancements have allowed astronomers to study Betelgeuse in unprecedented detail. Tools like the Hubble Space Telescope and advanced ground-based observatories equipped with spectroscopy and imaging capabilities have provided valuable data on Betelgeuse's surface features, chemical composition, and evolutionary stages. Recent studies have focused on Betelgeuse's mass loss mechanisms and the impact of its stellar winds on surrounding interstellar material, furthering our understanding of how stars interact with their environments and contribute to broader galactic processes. Additionally, Betelgeuse's variability offers insights into the core physics of stellar pulsations and instabilities. By studying stars like Betelgeuse, scientists can refine models of stellar structure and evolution, improving our ability to predict the behaviors of other stars across the universe. Beyond its scientific and cultural significance, Betelgeuse continues to captivate the public imagination, appearing in popular media and entertainment. Its portrayal in literature, film, and art underscores its status as a celestial icon and symbol of cosmic wonder. From science fiction novels exploring the consequences of supernovae to blockbuster films depicting distant worlds and interstellar journeys, Betelgeuse's influence extends far beyond the realm of astronomy. Looking forward, astronomers will continue to observe Betelgeuse's evolution and variability, awaiting future observations that might provide further insights into its ultimate fate. Whether Betelgeuse will indeed go supernova within our lifetimes remains uncertain, but its ongoing transformation presents a compelling opportunity to expand our understanding of the cosmos and our place within it. In summary, Betelgeuse stands as a testament to the awe-inspiring complexities of the universe. From its immense size and variability to its cultural significance and potential for a dramatic supernova, Betelgeuse continues to challenge and inspire both astronomers and enthusiasts. As humanity explores and unravels the mysteries of the universe, stars like Betelgeuse serve as beacons of discovery, reminding us of the vibrant and ever-changing nature of our cosmic environment. The launch of stellar material recently triggered an unusual disturbance in Betelgeuse's regular pulsing pattern. Its surface continued expanding, while the inner layers contracted, causing its usual 400-day pulsation to shift to a new 200-day rhythm. Astronomers believe that these pulsations will gradually stabilize over the next 5 to 10 years, eventually returning Betelgeuse to its customary 400-day cycle. As for the possibility of a Betelgeuse supernova, astronomers predict that such an event could occur at any time within the next 10,000 to 100,000 years, based on factors like the star's color, brightness, size, and age. Research indicates Betelgeuse is currently in the early stages of helium-to-carbon fusion. This process must progress through the fusion of heavier elements, oxygen, silicon, and finally iron, before the star's core will collapse under its gravitational force, leading to a cataclysmic explosion. Given Betelgeuse's distance of 650 light-years from Earth, any supernova that happens would take 650 years to become visible to us. It's therefore unlikely that we'll witness Betelgeuse's dramatic end within our lifetimes. A unique aspect of Betelgeuse is that we can actually observe its surface, unlike most other stars, offering astronomers an extraordinary opportunity to study how large stars like Betelgeuse evolve over time, especially during massive material ejections. Recently, astronomers also made an astonishing discovery, witnessing a star consuming its own planet 12,000 light-years away. With its prominent place in the night sky, Betelgeuse has captured human fascination for centuries, holding a rich cultural significance that goes beyond scientific interest. The star's name, originating from Arabic, has been interpreted as the armpit of the giant, though some scholars believe it could also signify a hand or shoulder. This physical association has been reflected in cultural interpretations of Betelgeuse across various societies. In ancient Japan, Betelgeuse symbolized a severed head. In Brazil, it was seen as a turtle's leg or a caiman's hind leg. The Sanskrit term for Betelgeuse translates to the moist one, linking it to Hindu astrology's Ardra lunar mansion and the storm god Rudra. Throughout history, Betelgeuse has held a significant role in cultural practices. In Macedonian traditions, it symbolized domesticated animals and agricultural life. In other regions like North Island and Melville Peninsula, Betelgeuse's rise marked the start of spring and lengthening days. Betelgeuse's cultural prominence is tied to its place in the constellation Orion, where it is recognized as the star on Orion's right shoulder. As one of the brightest stars in the sky, ranking 11th in luminosity, it continues to captivate artists, writers, and filmmakers. Recently, Betelgeuse has undergone remarkable transformations, capturing the attention of astronomers worldwide. From unprecedented dimming events to a massive material ejection,